few more folks joining us.
Hey, Brandon, how's it going?
Good.
We live?
Ed Bailey, are we live? Are we streaming this to YouTube? Are we going to record this, or what do we want to do? Because I can certainly record this, but with Zoom.
Yeah, I'll default to add on this. I'm just double checking just to make sure that we're not like on YouTube and somebody's like in the middle of eating lunch as we're talking about this.
In my teeth. I hope that shows up on YouTube.
Yeah, there you go.
Somebody else mentioned the same exact thing, Patrick, the other week. They were just like, I wish I would have known. I had an inkling, but I didn't double check. And there I was, like, changing a shirt in the middle of it. It's like, no, it happens.
It does. Give it a minute. Are you joining today or no? I didn't see what he was doing.
Who's that?
Jane?
Yeah, he just messaged me, said he's running a minute late on a customer meeting.
Well, let's just give him a minute. We'll get going in a second.
Yeah. Oh, we are live. Thanks, Ed. We'll kick this off in about 20 seconds here. Wait for a few more folks to pile on. All right. Hey, Shane.
Hey, Brandon, good afternoon.
We are ready to get started.
Here you go. Let me hit record. Just jumping off a customer call. Sorry I was late there.
Recording in progress.
All right, we're good to go.
Cool. Thanks, everybody, for joining today's Cribl office hours. We're going to be talking about basically designing the leader node for what some folks call rehydrating, some folks call repaving, some people call nuke and pave, many different terms for this kind of functionality here. Basically, replacing your instances with new golden images. So how does Cribl Stream work in this kind of environment? So for purposes of the recording, my name is Brendan Dalpy. I'm one of the solutions architects here at Cribl. I'm based in Kansas City. So let's get started. Today, we're talking about rehydration and repaving. No, we're not talking about what's on the right here, repaving the street. So we're talking about repaving in the cloud, how to make that work with Cribl Stream. What are the challenges that come with this? Not too many, especially when it comes to workers, pretty easy. But with the leader, there's a few challenges, so we'll talk through that. What about Git and GitOps as part of this workflow here? We'll talk about that real briefly. The introduction to the Cribl volume dir environment variable and why that's so important to this discussion. We'll do a live demo and hopefully everything will work correctly. And then obviously memes and stuff throughout this presentation here. So getting started here, what is rehydration or repaving? So I've got some links here. I see this a lot in the financial sector when it comes to cloud and the initiatives in cloud. So really it's the process of spinning up new servers with the latest patches already installed on them and decommissioning or destroying old servers that are now out of date. So instead of having a system continue its life and be patched in service, you spin up a new instance, run the application on that system. When a new image is available, you destroy the old one by unattaching the application, attaching it to the new one, and then having the system run from there. So basically, you might see this in an environment where there's a central team that controls creation of those golden images. Might be a very distributed IT team. And this really, for those that have adopted this model, facilitates a rapid pace of innovation while still controlling risk and making sure things are up to date. By going to these teams and saying, hey, your instances are now greater than 30 days, greater than 60 days in service, you need to turn them off. Otherwise, they'll be terminated for you. Basically, that ensures that patching is done appropriately. So there's some good articles out there. This definition here comes from Capital One's website, talking about AWS and DevOps in terms of rehydration, repaving. There's a nice article that Wells Fargo has put out around why they want to repave their entire platform on a daily basis. It's a little bit extreme in my opinion, but it's something that is doable. So if you want to go read through that, that's out here. So challenges rehydration with Cribl Stream. So with the workers, there is absolutely no challenge. You need a new worker. Okay, blow it away, start over. Your workers are stateless. They are not pets. they are cattle, and they can be terminated at any point. Auto scaling is supported. So basically get rid of them, create new ones, blue-green deployments, rolling upgrades, all of that is supported. Basically the workers will phone home to the leader, grab their configs, and they're good to go. Now, with the leader node, a little bit of challenge here because there is a state directory. So most folks that have worked with Stream have said, well, you're, stateless application, shared nothing architecture. Wait, what do you mean there's a KV store on the leader node? Okay, so a little bit of technical explanation here. The leader node does actually keep some state. This is important for things like scheduled collectors. So S3, REST API, those types of collectors. We will keep track on the leader node what the last time we ran that collection job, keep state there. There's also some additional state with inputs like Kinesis streams, for instance. The workers will keep track of the latest timestamp that they've collected from, which shards inside the Kinesis streams that they're also collecting from. There's some rebalancing that happens on a scheduled basis, and the rebalancing is reported back to the leader node, and the leader node keeps track of this, basically bookmarking where those workers are. So there is some important state that does need to be kept on the leader node if you are having this run in your environment. So now, if you're not doing any collectors, if you're not doing any Kinesis streams or things like that, okay, no problem. Just blow away your leader, pull the config back from Git, and you're good to go. But most folks will have some type of, call it stateful input that needs this. So what about Git and Git ops? Sure, yeah, could work. You could create a new instance, go out to your remote Git repository, pull the config down, start Stream, and you're good to go. But this still suffers from loss of state if your leader node is terminated. So I always like this. What kind of branching methodology do you use? So what's branching? I work in master or main. So let's talk about the Cribl volume dir environment variable. So as mentioned, this is an environment variable that can be set. This works across both virtual machines and container images. What this does is it turns the Cribl home directory, which is typically opt Cribl, default installations that can be changed. This will turn that folder into a read-only folder location. So most folks are used to going into opt Cribl local and seeing their config files there for the leader inside the groups or any type of local config changes for the leader node itself. Not anymore, or at least not with Cribl volume dir set. So the Cribl home directory is not changed. You untar the Cribl binaries into your destination, opt Cribl, Cribl home, whatever you want to call it. And it will not change until you upgrade the application, either untarring or upgrading. So this is great for container images where, quite honestly, it doesn't need to change inside the container. What we really need to do is keep the config that's active separate from the image itself. So this Cribl volume dir environment variable can persist modified data between containers or instances because all of the writes, that's config data, that's logs, that's state, anything that requires a write operation is going to be put into Cribl volume dir directory. So what happens at runtime is Cribl Stream will basically merge the two directories. And so you have the default of Cribl home and then any of the overrides from the Cribl volume dir location. Some of you that have worked with Logstream, previous branding, especially in versions 2.x, 2.2, 3, 4, before 3.0, this was called Cribl config location. So it's the same concept, it's just been renamed. It also, at the time of upgrade from 2.x to 3.0, we removed another environment variable called Cribl scripts location. So it got merged all into this Cribl volume dir, which has all of the writable components in there. And if you go out to the docs site, you can search for this Cribl volume dir and give you the definition of this. So really the question now is, what do you do with this and how do you make this work? So the backend for the Cribl volume dir can basically be anything. Just needs to be performance storage, not going to be a significant number of IOPS going out to this drive. So it's not like, we'll call it persistent queue, where you need ephemeral storage local to the system. You can use NFS for this. Wouldn't recommend it. If possible, use something like block storage. So across your cloud providers, this is kind of what you're looking at for Amazon, or AWS, Elastic Block Store or Elastic File Store, respectively. Microsoft Azure, so disk storage or Azure Files for NFS, and GCP, you're looking at persistent disks or file store for NFS specifically. And this volume doesn't need to be very big. It's storing the configs and log files. So a couple gigabytes will do you just fine for this. So how do you use this? I've put a few examples on the screen here across the different environments that you would deploy this out. So Docker on the left with the Docker Compose, you can obviously translate that to environment variables that you could run at the command line if you wanted to do Docker run. So basically mounting a new volume as part of your config here. So you've got this volume definition that I have here. This could be a local directory if you're just testing this on your machine, but for purposes of this, I'm including a volume. That volume is then defined here. So Cribl new volume. And here's the path that we're mounting this on. And you'll notice the path is the same that's used in the environment variable. So we're setting Cribl volume dir environment variable to the path to the config directory. So when stream starts with this container, we'll use the path to config dir as the persistent storage for the configs. Same thing happens with Kubernetes over here. So I've kind of ripped this out of our Helm charts. I've omitted quite a bit of the config for brevity here, but same concept here. We have an environment variable. I think this actually needs to be indented 2 spaces extra here. Sorry about that. But you're setting Cribl volume dir to the path to the config directory. And for Kubernetes deployments, you'd use a persistent volume for this, a PVC, to mount this directory. And so when this pod is refreshed, a leader node, we would mount the PVC to the new pod as it's created. So basically keeping that state across the systems. For things like virtual machines, actual operating systems running on whether it's AWS, Azure, etc., you would want to use something like systemd, and you'd want to override using systemctl edit Cribl. And then inside this override file, you can set an environment variable under the service section. So again, same concepts here: environment variable, environment variable, environment variable. So you're seeing kind of similar concept across all of these, no matter where this gets deployed. So I want to make sure, pause for a second here and look at the Zoom chat. So yeah, Michael Donnelly calling out, we don't want to use this for persistent queues. This is, yeah. Definitely. Okay, yes. So yeah, workers can be destroyed, assuming you're not using persistent queuing. With persistent queuing, you definitely want to make sure all the data has been removed from the persistent queue before you terminate those instances. So, and yes, this Cribl volume dir could be a NAS location, NFS, block store, it doesn't matter, as long as it is able to write and read at a reasonable speed. Awesome. All right, so we'll continue on here. So at this point, we're going to switch over to doing a live demo and kind of look at this in action here. So what I've done is I've actually spun up some Terraform to create an instance in my AWS Lab account here. So I've created a leader node. And what I've done is I have attached a second volume to this device. So you can see my root volume here is an 8 gig device. This contains the operating system and will also contain the Cribl home directory on it. There's a second volume that's been mounted here. This is a 10 gigabyte volume, block store volume. And we're going to use this as the persistent store for Cribl. I'm going to hop into this here, refresh this page real quick. And we'll take a look around and see what I've done to this system here. Elevate myself to root. So what I've done is I have set this up. And I have enabled the Cribl boot start command. You can see here, here's the Cribl service. I haven't made any changes to this file here. But if I go into the Cribl service directory, you can see I have an override.conf file, similar to what I was referencing earlier here with systemd. So here is my definition of the Cribl volume dir. And I've put this on a path called /mount/data. If we look at, oops. So we look at the file systems that are attached here. I've run the fdisk-l command, which will list out the file systems here. So I have NVMe 0N1, which is the boot device here. And I also have an NVMe 1N1, which is the secondary attached device. So you can see here, this is 8 gigabytes, and this is the 10 gigabyte volume here. Yes. So if we go and look at opt Cribl, where the application is installed, you can see here, I've actually created the Cribl user home directory inside opt Cribl. So all this data is written in here. So we have the default directories that you would get when you untar the application, bin, data, default, and all the good stuff here. So I'm going to go over to the data directory here. I'm going to take a look inside here. So this looks very familiar. You've gone inside this directory before. So here is local log. You can see some additional content in here, like lost and found. This is specific to this device. You would see this at the top level of your file system. So if I go in, I can see that I haven't changed much on the system here. This is just a standalone node. I haven't made any changes. You just started this system up. So you can see here's my console. It's currently in single mode. What I'm going to do is I'm just going to make some changes here. I'm going to convert this to a leader. We're going to restart this really quick. We're going to make some changes in the default, install some packs, just basically prove that this is not anything that's super crazy. No magician's hand here. We'll give this a second to restart.
If you have any questions, please just put them
Yeah,
in
it's
the
a great point to interject with any questions in the chat. Take yourself off mute. So here we go. We now have a leader set up in distributed mode. We have a default group. I haven't installed any licenses, so we're just going to leave this as is. I'm going to go to the packs here. I'm going to add some packs from our dispensary. So I'm going to pick on, I need some syslog data here. I need some Windows data. Oops. That's fun. Need some Palo data. So here we go. I've installed some packs on the system. I could go and configure some inputs. I want to enable my syslog here, have this come in. I want to enable my Splunk TCP. I want to get some Splunk data in here. So I'm going to go ahead and I'm going to commit my changes. Here's all the defaults here. Commit these changes, and I'm going to deploy this out to the system. All right. So all of this looks good here. We've got, let's say, Stream has now been configured for what I need it to do. I've got my workers checking in. If I had workers set up, I don't have any set up in this environment here. But now what I'm going to do is I am going to use my Terraform on the other screen. I'm actually going to run a command called taint, and it's going to mark the leader node as something that needs to be replaced. And so now what I'm going to do is I'm going to apply the changes here. And this is actually going to go over, and if you watch this here, we'll refresh this. This instance will go from a running state to stopping. It's going to shut down. And then we're going to see a new instance be created as part of this process. So it just unattached the volume. So you can see the volume has now been unattached. This instance is now shutting down. So this process takes about 60 seconds, 120 seconds to complete. Now, if you were doing this with containers, this could be as fast as a couple seconds to do something like this to update. So just we're using virtual machines for purposes of ease here. Any questions from the team so far while we're waiting? It's another great point to take any questions. It's like watching paint dry.
Nothing yet.
Okay, so now the instance has been terminated. Yasmin has posted a question in the Zoom chat here. State directory, does it maintain the sample files as well? So the sample files are still in the Cribl volume dir directory, but they're not in the state directory. They're actually in a data samples folder. So you'll see that as part of the different groups. So if you went to local groups, your group name, data samples or samples data, something like that, you would see your actual sample files that you've captured or uploaded to the leader node. All right, so here we go. We now have a new running instance here. So we've terminated the old one. We have our new instance. Just to show this, I'm going to try and reload this page. This instance does not exist anymore, so we're going to get spin there. So what now I'm going to do is I'm going to put in this new address. And here is the new leader node. I'm going to log in. So I had my password that I set. I'm going to go to manage stream. You can see we're in leader mode already. I'm going to go look at the packs here. So I still have the packs that I installed on the previous instance here. They've been moved over to this new instance as part of the rehydration of this machine. So we can see that this old instance, this old instance here no longer has the attached storage, and this new instance here has both attached volumes, the OS and the config directory. So I've done this with Terraform, and I'm happy to share what that looks like. I'm going to stop sharing this screen here, and I'm going to share a slightly different screen. So pull up my PyCharm editor here. I'll skip some of the Terraform, but really the interesting part is what I've highlighted here, this user data on the instance. So it's actually doing a fresh installation of the logstream binary every single time that this instance starts. It will set up the override here. You can see this /mount/data. It then creates the mount point. This blkid command will actually check to see if this device already has a file system created on it. If it doesn't, creates the file system, goes ahead and mounts it on this mount point, make sure the permissions are correct, and it starts up Cribl Stream. So as long as the volume is attached correctly, everything looks good to that device. So what you could do here as part of this, if let's say you were working in AWS with a virtual machine, you could use something like a Lambda function. And that Lambda function could do an unattach of the device. It could hold it, spin down the instance, recreate a new instance with your golden image, reattach the device, spin this up. So all of this could be done with some basic automation. Now, if you're doing, let's say, the Helm charts, Kubernetes, what you could do is basically just upgrade to the latest version, and the Helm chart Kubernetes actually takes care of keeping the persistent volume claim and persistent volume inside the Kubernetes environment for you. And you don't have to worry about that config volume disappearing, but we'll upgrade your container images to the latest version that you want there. So just a couple basic commands to handle that. So a couple different ways of doing this in your environment. The other way, let's say you're using AWS with an auto scaling group. You could create an auto scaling group for the leader of size 1, and you could do, let's say, a blue-green type deployment where you have a new version of the auto scaling group template, and that is a newer version of the Cribl Stream binary. So your older one is on the last version, your newer one is on the obviously the latest version or whatever you want to upgrade to. You can have the auto scaling group automatically terminate the old instance and recreate a new one, have that volume mounted there. So we're doing this with an EBS volume here. You could do this with an NFS mount point. There's just a couple different commands to do that. I don't have that set up as part of this demo, but it's just about as easy as doing this here. So questions on this here? Cool. So we got to see how to use it. We did a live demo. Everything worked. Yay. So for those of you that have held your questions till the end, I'm happy to take those. Otherwise, we can say thank you for attending today. I'm also happy to go through other content if we're interested in talking about different topics. You know, I'm done with today's pre-planned content. We can talk about other things too, if that's of interest to anybody on the call.
Any more questions? You can come off of mute or put in the chat. With nothing else, Brendan, appreciate the content today. And thank you everybody for your time.
Thanks, everyone. See you next time.
Thank you.
Recording stopped.
Cribl's innovation is its simplicity and its scale. Let me explain what that means. It's simple in the sense that it delivers immediate ROI. Customers get what it does right away and where it will fit. And it's scalable, which is its superpower. It allows for organizations for the first time ever to scale their data infrastructure in a manageable way.
You know, at the foundation, the thing that really struck me about what makes Cribl so innovative is that they collect an enormous amount of data. They shape that data, they route it, they do it across infrastructure and security and applications. They can do it at a massive scale, and they can do it with low code or no code environments that, you know, getting all of that to work is incredibly difficult.
Cribl really empowers organizations to route their data to whatever place is best to store it and whatever place is best to analyze it. That's the sort of freedom that people just haven't had with machine data or with observability in the past.
Investing is very personal. We see so many opportunities and there are plenty of good ideas, great ideas. The team is brilliant. And to a person, people reminded me of that, customers, vendors, etc., competitors. And then I watched former colleagues join the company also, and it just gave it it gave it like the personal fabric that I felt like this was a group that I wanted to be in business for a really long time.
What convinced us to invest in Cribl was the right team, the right product at the right time, addressing the right market opportunity.
The team is really what got us most excited. I mean, in the end, as venture investors, we're investing in a group of people that we think have a chance to do something really disruptive. And when we had a chance to meet the founding team and the management team that they had built, we were convinced that this was a really special opportunity.
I think Cribl is going to be a new strategic layer in the data stack. It's as simple as that.
The process of getting into Cribl as an investor in 2021 was not for the faint of heart, which I interpret as, supply and demand. If more people want to be involved with the company than are allowed, it suggests to me that they're onto something.
We're honored to be partnering with the team at Cribl and are huge believers in the value that they can create for enterprise customers of all sizes, and we look forward to the journey ahead.
Cribl is one of the fastest growing companies we've ever seen in the enterprise space, so that growth alone was something that was really exciting to us.
At Sequoia, we like to say if data is the new oil, then Cribl is the new pipeline.
I believe Cribl has the opportunity to be one of the largest software companies of our generation. The market is enormous, the product works magically, and we're winning.